Alright, shell method is a very useful way for finding volumes when you don't want to change your variable. In the sense that if we want to find the volume when we rotate this particular region around the y-axis, well, we would first have to solve it for y and get a piece from 2 to 3, from the vertex to there, and then another piece down here, and essentially it'd be a square root, a positive square root in terms of y, and a negative square root in terms of y. So it would not be very easy to do. But in order to do it the way we've been doing it, we'd have to somehow get two functions and do outer minus inner, right minus left. So clearly this is not easy. It's doable, but it's not easy. Okay, so I was hoping I could erase that. But what we're going to do is we're going to keep things in terms of x. And so if you have a rectangle right here, what the shell method does is it says that the formula anyways is 2 pi times the integral from a to b, the distance to the axis. So how far is this distance right here? And it's x in this case. And then the height is actually just our function in this case. And then we'd integrate it. It's pretty straightforward. The distance to the axis can get a little tricky, but other than that, this is how you can rotate around the y-axis without changing your variables into y's. Now, what it's essentially doing is taking this rectangle and rotating it around an axis. And it's basically creating a layer of toilet paper, so to speak. And if I were to look at that, the area of that would be base times height, where the base is the circumference of this particular section of toilet paper, which is where the 2 pi r comes into play. 2 pi times the distance to the axis. And then the height is this piece right here. So that's where the formula comes from. Let me show you another example. Okay. Here's a function 2x squared minus x cubed is the cubic function, and then we have the pink function, which is a line, negative 3x. They intersect at 3, negative 9. And if we want to rotate this region right here around the y-axis, it would be actually impossible to solve for y. We couldn't write this in terms of y, so we have to use shell method. So the volume is going to be 2 pi integral from 0 to 3. This distance from my rectangle to the axis is x. The height is going to be the top function minus the bottom function. And then I'll just plug it into my calculator. Okay, if I were rotating around, let's say x equals 3. Okay, then it'd be the volume, 2 pi. This time the distance between the axis and the rectangle is 3 minus x. Where the rectangle is at x, and this is at 3, this distance between 3 and x is 3 minus x. It's always right minus left, and then the height would still be the same. Alright, let me give you one more example. Let's say you were rotating it around x equals -1. The volume would be 2 pi, 0 to 3. But this time, right minus left would be x minus -1. And if you think about it, this distance right here is the distance for x plus 1. Times the height. And that's the shell method. It's pretty straightforward.